Here we're asked to prove this statement using proof by induction. So we're going to start, as we always do, with our first step, which in this case is when n is equal to 1, because we're in the positive integers. So looking at the left-hand side, we have the sum from I equals 1 to 1 of I squared plus 1 times I factorial. So when I is equal to 1, this is going to be 1 squared plus 1 times 1 factorial, which is 2 times 1, which is 2. On the right-hand side, we're going to have 1 times 1 plus 1 factorial, which is 2 factorial. 1 times 2 factorial is 2. So it's true for the base case. Step 2 is our assumption. So n is equal to k. And we're going to assume that the sum from I equals 1 up to k of I squared plus 1 times I factorial is equal to k times k plus 1 factorial. Step 3, when n is equal to k plus 1, our inductive step. What we want to show is that I equals 1 to k plus 1 of I squared plus 1 times I factorial is equal to k plus 1 times k plus 2 factorial. So that's what we want to show, and we're going to do this now, starting with the left-hand side. We're going to break this sum up into the sum from I equals 1 to k of I squared plus 1 times I factorial plus the k plus 1th term of this sum. So when we substitute k plus 1 in, we're going to get k plus 1 squared plus 1 times by k plus 1 factorial. Now we're going to make the substitution for the assumption, because this bit here is our assumption, so that is equal to this. So that's the same as k times k plus 1 factorial. And then we still have the rest, which is going to be, I'm going to expand this out in here. I'm going to get k squared plus 2k plus 2 times by k plus 1 factorial. Now, the first thing I notice here is that both of these have a k plus 1 factorial in it. So I'm going to factorize out that k plus 1 factorial. And I'm going to get left with k plus this thing, k squared plus 2k plus 2. So that's k plus 1 factorial, k squared plus 3k plus 2, which is equal to k plus 1 factorial. And factorizing this is k plus 2 times k plus 1. But using the rules of factorials, k plus 1 factorial times k plus 2 is k plus 2 factorial. And then I've still got this times by k plus 1 on the end. But now if I look back, that is exactly what I'm trying to show. So that is equal to the right-hand side of that statement. And then our final step, which we must never forget, step 4, our conclusion. The conclusion states that something along the lines of, hence, by mathematical induction, since it is true for n equals 1 and it is true for n equals k plus 1 when it is true for n equals k. It is true for all n in the positive integers.